Hey, my name is Mark Johnston and I do STEM education. Today I'm going to show you how you can print a vector image, kind of like that, onto the screen of the VEX IQ second generation brain. So in VEX Code IQ, you have the ability to code in blocks or in a text project. Blocks is a little bit too basic for what we want to do. It's possible to do this in blocks, but it would take a long time. So what we're going to do today is we're going to do this in C++. So we're going to say new text project. So notice you do have a choice between Python and C++. And one of the major differences between these two is that Python is interpreted by the brain. And that's one of the reasons why the first generation brain can't use Python. It doesn't have the computing power to handle that. Whereas C++ gets compiled on your computer and then sent to the brain. And so this compiling of the file into a binary and sending it to the brain is what is going to allow us to have a large file, a lot of lines of code in order to generate these little images by drawing one pixel at a time. If we were to do that with Python, we would run into memory issues in sending that large amount of information to the brain. So we're going to do this project in C++. You could do some drawing in Python, and a few hundred lines, but we're going to do about 1,000 lines of code in this C++ program to get a nice little image drawn on our screen. So I'll select C++. Notice that we get this screen that kind of starts with some of the stuff like namespace, VEX, and then we're going to type our code right here. Now, the code is very simple. It's not super complicated. We're just going to set up an array. And so you can even see over here on the left-hand side where you can say variables, and you can see numeric 2D array. And I can even click and drag it over here. And I'm going to call it list, make it easier. And we have to declare how many rows and how many columns there are going to be. I'm going to do 1,000 rows and just 2 columns, because I just need an X and a Y coordinate. And I'm going to replace these later. All right, so I'm going to go ahead and delete that and just leave that empty for right now. And I'm going to jump down here a couple lines, and I'm going to set up a for loop that is going to loop and print a pixel for every coordinate. And we'll get the coordinates in a little bit. Okay, but I'm going to show you this first. Okay, so I'll say, I can go to Control up here and use these by clicking and dragging. Control, I can say 4. Okay, so I'll drag the 4 over there. And then there you go. It's already got it set up for you. What this means is for the integer I equals 0. And then if I is less than or equal to 10, then do this, do whatever's in this for loop. And then I++ means add 1 to I each iteration. Okay. What I'm going to do is go ahead and change this to 1,000 so that it's going to run 1,000 times. And each time it runs, I'm going to have it change. And so I'm going to use that I, that variable I, which changes every time this is looped. And I'm going to have it use the list information each time. So I'll explain it here a little bit more in a second. But let's go ahead and go to the looks area right here, looks, and I'm going to look for the pixel. There it is. And I'll just drag that in there also. Oh, right there. brain.screen.drawPixel and then 0, 0. So that's going to draw a pixel at 0, 0. Now, this IDE or VEX Code that we are using right now has some nice documentation. If you look at where it says that brain screen draw pixel 0, 0, if you click the little question mark, this stuff pops up over here behind my head, and we can see that the screen we're printing on is 159 pixels wide by 107 pixels tall. And so that's going to be important in knowing exactly where we want all of our dots to be printed. And so, that is something if we were to print something that was, 300 pixels wide, it wouldn't show up on the screen. Okay. So, you can play around with that, change the pixels. That would be a great place to start, is to just go ahead and have the brain plug it in, print a pixel at 0, 0, and then run it and see that it did it. Okay. That's a good progression. Maybe draw a line and some rectangles, try some different shapes and things that you can draw on the brain so you're getting an idea of it. Another thing to do is to just run this list like this. You could say, draw a pixel at 0, and then right here you could put I, right? Or II. Actually, II might be kind of fun. If you did draw a pixel at II, I'm going to go ahead and plug in my brain and show you this. And so we don't need this right now. I'm going to cut that out for a second. Okay, so all we have now is a for loop where it's going to draw a pixel on the brain up to 1,000. We don't even need 1,000. We can just do like 159, for instance. Okay, because 159 is the greatest. And so what's going to end up happening is if you see the screen over here, the first time it goes through this for loop, it's going to draw a pixel at 0, 0. And then it's going to draw a pixel at 1, 1, and then 2, 2, and then 3, 3, and then 4, 4, and then 5, 5. And you might think, well, hey, when the X and the Y values go up, it should be going from left to right and from low to high. But the way that this screen is, the way you access these pixels on the screen is that left and right, or from left to right, is going up, but from top to bottom is going up in value. Okay, so we're going to notice it's going to go from left to right, but it's also going to go down. All right, so that's the code. I already have some stuff on this brain. I don't want to lose it, so I'm going to put it into slot 8, kind of my junk slot where I have my junk drawer where I put stuff I'm working on, and then just call this draw line. All right. And it should be downloaded, I think. Download. Yep. Okay. And then I'm going to have to unplug it and to hold it up here. And then I'll go ahead and push play with my other hand. Uh-oh. Okay. So there's green in the screen, which the my chroma key green screen doesn't like. Okay. Here, I'll hold it like that. And then I'll push start. Oh, and it did it almost instantaneously. Notice it didn't print like do. It just went poof, like drew it on there right away. Okay. So that's what that did. If say I did draw a line at I and 4, 5 or something. Here, I'll download that again. Download. Okay. And then I'll run it again. Haha. Notice the line. Okay, it drew it at the X coordinate, right? And then the Y coordinate was fixed at 5. So it was 5 down and then X all the way across. So that's how that works. We're just using this ability to draw pixels. And of course, you can make it even easier. If you're just drawing a line, you can just use the draw line function that's right here, brain screen draw line. And you just specify the XY starting place and the XY ending place, and it draws a line. Okay. But we're going to actually do something where we have a lot of little tiny points. Okay. It's like how a printer works. printer puts a little drop of ink and then a little drop of ink somewhere else, a little drop of ink somewhere else until you get an image. Now, if I wanted to get really fancy, I could figure out where to put red, green, and blue pixels, and then those red, green, and blue pixels would combine to make a really fancy color picture. But I'm not going to get that fancy. I am just going to do black and white, and it's really going to be white pixels on a black background. And so now we need our points, right? Because each time I want it to pull in the points into this so that it will print the stuff that I want it to print. So I got to figure out how to do that, right? That's where, if I just undo, I think, undo a bunch. No, because I already saved it. Okay, here we go. Control V. Yeah. All right, so I have my list started right here. And I'm going to paste in some values in there for the list. And then it's going to go to the list and it's going to pull those values into my little for loop. And it's going to run it 1,000 times, printing a little pixel in each one of those spots. So there's going to be 1,000 pixels drawn on my brain screen to give me an image. Okay, so let's go ahead and grab an image. I have a Google Chrome browser open over here, and I already have found an image. Okay, so I went to Pixabay. It's there's free copyright, free stuff there. I can't vouch for what you might find there, so use that at your own discretion, your own caution. But yeah, if you go to pixabay.com, there's this button here that says vectors. And, if you say you wanted a cow for some reason, I don't know why, but you could type in cow. Now, you want to find the simplest possible drawing. Like this is a pretty good one right here. If I click on it, now if I look under free download, if you got to make sure this says SVG, you got to select vector graphic and it has to say SVG. If it says AI, it's not going to work for the tool that I'm going to show you how to use. Okay. I'll put a link to Pixabay and to the snake if you want to use the same thing. If you want to follow along exactly with what I'm doing, then I'll do that for you. And so here's the snake. I would say download and then vector graphic SVG and say download. Of course, you can donate if you want to whoever made that. And then there's your snake.svg. Now, I've noticed that some of the SVG files are not the same format, so there's a little bit of trial and error here. I'm going to go to the next tool, okay? And that's Coordinator. It's a spotify.github.io/coordinator. I will also put this link in the description. But you select the file that we just downloaded, and there it is, my snake.svg. And once it's selected, it loads it in right away. And now what we need to do is just go refine the dots. Notice there's 2,354 dots there. I'm going to go ahead and just change that manually. I'm going to type 1,000. And then under scale, I'm going to do, notice if you do the slider can only go down to 1. Okay, but it will let you do a decimal. So I'm going to put in 0.2. And that's a little small, maybe like 0.2, 0.25. Yeah, let's do 0.25. Looks pretty good. And then also the X offset is going to be 0, or translate it, and then the Y at 0. And then the dot radius I'm going to put at 1. There's going to be a better indication of what my little snake guy there is going to look like. Okay, so it's going to look something like that. And instead of .25, I'm going to use .2. Okay, so those are the refined dot settings I used. Number of points 1,000, scale 0.2, translate X 0, translate Y 0. And notice that if I do translate the X or the Y, it just moves it around on the screen. But I don't want that because I want this to print in the upper left-hand corner of my brain screen. Okay. Dot radius 1, and then color doesn't matter. Okay. Now I go to the 3 where it says get coordinates. Okay. I'm going to go to CSV. I'm going to do Control A, Control C. Notice now there's 1,000 lines of code or 1,000 lines of items in here. All right, now I'm going to go to Sheets. I'll go to Google Sheets, and I'll say a new one. And I'm going to paste those coordinates into the sheet. Okay, I'm going to delete that top row because we need to do a little bit of cleanup on this data that we're going to use. Because notice that it's like 103.1000084 whatever. We want to just use just the rounded number. Okay, so the first thing I'm going to do is go to Data, and then say split text to columns. Okay, data split text to columns. And there we go. And then I'm going to create a column over here where it's going to have everything formatted exactly like I want it. Okay, so I'm going to put equals, quote, open curly brace, close quote, and then round, R-O-U-N-D, open parenthesis. Then I'm going to select A1, comma, 0 for I want 0 places after the decimal, and then a close parenthesis. And if I were to just push enter right now, there you go. You've got 103 with a little open curly brace on the left. I'm going to go back in there and keep editing. Okay, so I'll do an and, so Shift 7, and I need to put quote, a comma, close quote, and then and round of this second item right there. Oops. And comma 0. I'll put this line of text in the description as well. All right. So then let's do that. And then I need to do and open quote, close curly brace, and a comma, and then close quote. Enter. Okay, so that gives me a nicely formatted, this first point is at 103, comma, 122, and then comma. Now, this is probably going to end up giving me, because I rounded, I might end up getting some duplicates, but that's okay. I'm not really too worried about efficiency here. And you might think, well, 1,000 lines is a lot, but it really isn't. It's not going to cause any trouble. So I'm going to zip all the way down, scroll all the way down to the bottom. So I have that second place highlighted, and then I'll go all the way down to the bottom, hold down Shift and click, and then Control V, and then boom, there it is. Those are all my coordinates. Now if I scroll back up and then I select them, and then I'm going to do Control C. Now I'm ready to go back to VEX Code. So here, I'll just go ahead and paste, boom, Control V. And notice that, like, if this was Python, it would not like the fact that, you know, these are not aligned properly. And honestly, I don't like it either, so I'm going to fix it. If you select right from right there, and I push Tab twice, but I don't want to go down and do that at 1,000 lines, so I'm going to highlight all the text right to here, and I'm going to push Tab twice. And then now I have it properly indented. I'm going to delete that last comma. I don't need it. We have this beautiful, long, crazy list right here that's called list. And now we want to pull one of those items out each time. And we can get those items by their index number, okay? And so this very first item on the list, I want to draw a pixel at 103, 122, at X103, Y122. And if I want to draw a pixel there, I could just type in, you know, draw a pixel every single one of those lines. And that's something you could do, but it's just kind of messy and not quite as nice. And so what I'll do here is I will say draw pixel, and right here is where I'll put the index of the list. So I'll say list, and then I'm going to use open and close brackets, and it's going to be list I is going to be the row. And so this first time it runs through this for loop, the I value is 0, and my list index starts at 0. So it's going to be list row 0, and then the column of this one, of the X coordinate, is going to be the 0th column, okay? Because the first place, like for instance, this here at the end, this last item, we see 33, that's the 0th index place. And then this is the number 1 index place, okay? I don't want to say first because the 0th is the first. I know it gets a little confusing, but in computers and in most programming languages, all that I know of, indexing and counting starts at 0. 0, 1, 2, 3, 4, okay? So we have our first coordinate right there, and I'm going to go ahead and copy that and paste it in the next spot. And I'm going to make that the first place, okay? So this right here, brain.screen.drawPixel list I 0, and then list I 1 is going to bring in those the XY coordinates that I need to say I want to draw a pixel there. Once it draws that pixel, it's going to loop back around. It's going to add 1 to I, and so then I will be 2. Which means when it comes back down through here, this I right there will be 2, which means it'll be the second row, and then it'll be the third row and fourth row and sixth row and so on, all the way through our 1,000 rows. And it's going to do this very fast. And so at this point, I am ready, and we're going to just change this to snake. Okay, I'll rename it. Uh-oh. Oh, there's already, okay, I already called one snake. Let's call it snake 2. Rename, snake 2. And then I will download that into slot 8. It is downloaded. I'm going to unplug so that I can hold it up to the screen here. And let's, boom. Oh, he's too tall. He's too tall, but I bet if I printed him sideways, he would be just right. So now is where we think about our geometry or our math class and our XY coordinates. And check this out. I'm just going to change this code so that the X will be in the Y spot and the Y will be in the X spot. And, you know, you can do this whole thing where you can translate, where you add a value to it to move it over, or you can scale it to make it, you can multiply it by a scale factor. All those things are still valid. They work. And so that's why a lot of people say that, you know, it's good to be strong in math for programming because those are the similar concepts you would use. All right, let's go ahead and run that and see our snake, sideways snake. Beautiful. And there he is. All right, guys. Well, that's pretty much how to do it. Make sure you check the description down below. And I really hope that you enjoyed all this video. And if you did enjoy it, I hope you would like it, subscribe, share it with a friend, and then also make sure to join our Facebook group so that you can post pictures and images and questions. All those links are down in the description below. Thank you so much. Have a good one.